Sadness. Okay, so the point estimate in the middle of the TIE fighter, the confidence interval is 0.672. Then you add the error on one side and subtract the error on the other side, and you get 0.701 and 0.643. So that's pretty easy. Number 6, you've got to do a statement. So I am 95% confident that between 64.3% and 70.1% of all teenagers have cell phones. And if you're wondering why that number is so low, that's because this data was originally from, I think it was 4 years ago. And also, excuse me, you have to remember that this includes 13-year-olds. Teenagers technically include 13-year-olds, not just 18-year-olds like yourselves or 17 or whatever you guys are. Okay, this is time to stop the video and try example 2 by yourself. You gotta try example 2. You should pause the video right now. Ooh, ooh. Did you? Did you pause the video? Did you try it? Or are you just watching it? I hope that you're taking notes some way or another. Even if you don't print this out, even if you're just trying this on your own, I hope that you are doing it and not just listening. Because that's how you learn math, by doing it. All right, a survey was given to 498 U.S. adults where they were asked, who are the more dangerous drivers, teenagers or people over 65? I wonder what you guys would think about this. I don't know. I'm guessing you probably think people over 65, but maybe some of you think teenagers. But anyway, in this case, 71% answered teenagers, 25% answered people over 65, and 4% had no opinion. It's an interesting idea there. Just don't ask me. I have no opinion. I just don't care about this. In this case, n is 498. Your p-hat, you don't actually have to have n at this point. You could figure it out if you really wanted to by taking p-hat times n. But the whole point of having n was to figure out p-hat in the first place. So there's my p-hat and my q-hat, my fat, my, I don't know. Okay, part 2 is that we just need to check that this can be done. So I'm going to take the smaller percent, 29%, multiply that by 498. I think we're good. I think that's more than 5. I don't even need to put it in my calculator. All right, number 3, we need to know the z-score for a 99% confidence interval. Remember, this data is actually in that corner. I don't remember if it was on A16 or A17, but it's like in the bottom corner. You can just look at it that way. But if you want some practice about how to actually figure this out on your own, which you should know, it's about 0.5% on either side. And if you look up that number in the middle of A16 or A17, you get negative 2.575 and 2.575 over here. So our one that we're going to use is the positive one, the 2.575, like always. Technically, we're using both because when you're adding the error, you're using the positive one, and you're subtracting the error, you're using the negative one. All right, for 4, it is 2.575 times the square root of 0.71 times 0.29, all divided by 498, and that gives you the error, which is 0.052. Okay, then making my TIE fighter. I should actually get an actual TIE fighter noise. I'm not going to do that, guys. I'm not I'm not going to do any of those things. I don't know why I keep saying I'm going to do things and then yeah, too much work. Okay, so there's me adding the error and subtracting the error and then making my statement. I am 99% confident that between 65.8% and 76.2% of U.S. adults think teens are more dangerous drivers. Okay, then we've got the minimum sample size formula, which is really helpful for real life situations. It tells people how many people they would have to ask to get a certain amount of accuracy in some data. As the formula, n equals p hat times q hat times z sub c divided by e squared. Okay. Excuse me. Okay. If you wanted to figure out this formula, you could have actually gone back. Let me find that. You could go back to this formula right here and solve for n. First you divide by z sub c, then you would square it to get rid of the square root, then multiply by n, and then divide by, and then multiply by n, and then you would have to essentially cross, or you'd have to divide by the rest so that you could get n by itself. So it looks like that. Also, let's say that you don't know the minimum, you don't know p hat or q hat. So if you don't know p hat or q hat, they love doing this question in the AP test, by the way. If you don't know p hat or q hat, use 0.5 for both. Okay, you're running a political campaign. This is a super real life conversation here. You're running a political campaign. I actually have a friend who does this and wish to estimate with 95% confidence the population proportion of registered voters who will vote for your candidate. Your estimate must be accurate within 3% of the population proportion. Find the minimum sample size needed when a preliminary estimate of 31% is given, or no preliminary estimate is given. So we got two parts to this. The first part, I'm going to use my formula, n equals p hat q hat z sub c over e squared. Okay, so on this one, your p hat is, oh, by the way, this right here, that is your error. You want to be within 3%. So p hat is